our channel. This is Teacher Julie.
Hi! Hi again! Welcome back to our channel. This is Teacher Julie and I will be with you again for this another session of modules. Joke lang. Okay, so our topic will be about remainder theorem. Yes, you're very good at it. It's just a remainder. So what's a remainder theorem? A remainder theorem states if a polynomial p of x is divided by x minus r, then the remainder r is equal to p of r. Did you get that? Yeah, I know it's very complicated when you see a lot of variables here. P of x here will stand as our dividend. X minus r will stand as our divisor. So if we're going to use this remainder theorem, then we can get automatically our remainder. Okay, to understand clearly, I will have presented to you, I'll give you an example here. What is the remainder when 10x raised to the power of 159 minus 5 is divided by x minus 1? What did you observe? Yes, if you are going to notice the exponent of our variable is 159 and it's a very large number. So if I will be asking you, are you going to use the synthetic division that we learned in our previous video? Or are we going to use the long division? Now, take note, our exponent is very large. And since it doesn't ask for a quotient, it only asks for the remainder, then this is the time that we are only going to use the remainder theorem. So this is how we do it. Our p of x will be our dividend. So p of x is equals to 10x raised to the power of 159 minus 5. And our x minus 1 will be our divisor, which is x minus r. So to get our r, we have to get our divisor. So x minus 1 equal to 0. So x is equals to positive 1. So our r is positive 1. So therefore, our p of x will no longer become p of x, but it will become p of r. So this will become p of r is equals to 10x raised to 159 minus 5. And our r, since we already solved for our r, which is 1, so r here will become p of 1 equals. So p of 1, we just substitute our x by 1. So this will become 10 times our x will become 1 raised to the power of 159 minus 5. That's it. Next, we simplify. So this will become 10 times 1. We cannot do that one because applying again PEMDAS. So we just copy our 10. Then simplify 1 raised to the power of 159. So what's the answer? Yes, it's only 1. Why? 1 raised to the power of 159 means 1 times 1 times 1 times 1, or it's equivalent to 1 multiplied by itself 159 times. The answer is only 1 minus 5. Simplifying our answer, so we can do multiplication before we do subtraction. So 10 times 1 is 10 minus 5. Or 10 minus 5, answer is 5. Therefore, our p of 1 is equals to 5, and 5 automatically is what we call our remainder. And that's how we apply remainder theorem. When p of r automatically is equals to your remainder. So no need of using the long division and the synthetic division. We can get automatically our remainder. And here, the remainder is 5. We'll have example number 2. Find the remainder when x cubed minus 2x squared minus 11x plus 12 is divided by x minus 4. Since our problem calls for a remainder, you can use synthetic division, you can use long division, you can use remainder theorem, whichever you are most comfortable with. So since I will be the one to solve this one, I'll be utilizing the remainder theorem. So what's the remainder theorem? So our polynomial of x is, our dividend is x cubed minus 2x squared minus 11x plus 12. And our divisor is x minus 4. So our p of r, so we have to solve for our p of r here. Just copy x cubed minus 2x squared minus 11x plus 12. We substitute our p of r by x minus 4, x minus r. So automatically our r is 4. Did you get that? Okay. So the value of r is 4. So x cubed will become 4 cubed. Minus 2, x squared will become 4 squared. Are you following? Minus 11 times x, x will become 4 plus 12. That's how we do it. We just substitute the value of our divisor, which is 4. After the substitution, we will be simplifying according to PEMDAS. So, since it is PEMDAS, we will simplify those inside the parentheses, exponential, and then that's the time we can multiply. So this is 4 cubed, we have to simplify. So 4 cubed means 4 times 4 times 4. So how much is that one? Yes, that is equivalent to 64. Next, you cannot multiply 2 times 4 because 4 has still an exponent. Copy minus 2 and then simplify 4 squared. So what is 4 squared? Yes, you have to multiply it by itself twice. So 4 times 4, answer is 16. Next, since there are no more exponential form here, then we can do multiplication. So negative 11 times 4, we can get our answer, which is negative 44 plus 12. Now we can do multiplication since there are still 2 times 16. So we can do multiplication. The rest you can copy so that you will not be confused. So 64 multiplied negative 2 times 16. Answer is, yes, that's negative 32. Copy negative 44 plus 12. Since this is operation of addition and subtraction, then you can subtract and add whichever comes first. So you just subtract whichever comes first. So 64 minus 32. How much is that one? Yes, that is equivalent to 32. Minus 44 plus 12. Or you can use your calculator. You can 32 minus 44 plus 12, or you can do 32 minus 44. So you can have that one. 32 minus 44, take note, that is subtraction. So apply the rule for subtraction. You change the sign of the subtrahend and proceed to the rule of addition. So 32 minus 44, the answer is negative 12. Am I right? And then copy plus 12. Then negative 12 plus 12 is equals to 0. So the remainder is equal to 0. So when x cubed minus 2x squared minus 11x plus 12 is divided by x minus 4, the remainder is 0. Take note of this one. When the remainder is 0, automatically the divisor is a factor of the dividend. I repeat, when the remainder is equals to 0, the divisor is a factor of the dividend. Did you get that? Because in our factor theorem states that when p of x is divided by our x minus r, and our p of r is equals to 0, automatically our x minus r, the divisor, is a factor of our polynomial p of x. That is what our factor theorem states. That's it for today, guys. I hope you learned something today about factor theorem and then remainder theorem. And if you find our presentation very boring already, you can give us a challenge and then we will try our best to do it.
Just write down at the comment box below on what kind of challenge you want us to do.
So don't forget to subscribe and like. Thank you.